Why does light bend when near a gravitational field? Newton's laws cannot explain this, but Einstein's general theory of relativity does. In this theory, the gravitational field is actually a warping of space-time by some mass, like a planet. Just as a massive ball will make a dent on the surface of a waterbed, or, as you can see here, a bowling ball on a flat surface, it warps the surface. The warped space-time affects motion of other objects, just as a marble rolling on the waterbed gravitates to be dead. A black hole occurs when a star becomes so small and the gravitational force of the surface becomes so large that even light cannot escape the surface. Anything in its vicinity will be attracted by a warped space-time and lost forever, as shown in this diagram. So when an object is inside this black hole, inside this large well, it cannot get out. Nothing can get out, not even gravity, not even light. A photon escaping from the vicinity of a black hole will use up a lot of energy in doing so. It will not slow down. It can't slow down, but it loses energy according to the equation E is equal to hf. Therefore, its frequency gets smaller since its velocity stays the same. Velocity is the speed of light, stays constant. Velocity is frequency times wavelength. If the frequency gets smaller, the wavelength gets bigger. So we say that light leaving the vicinity of a black hole, not from inside the black hole, but from the vicinity of the black hole, is redshifted, as we see here. It stretches, which means it goes toward the red. This is called the gravitational redshift. So this is as if light were traveling uphill. It doesn't slow down, but it does lose energy and becomes redshifted. So this explains why light is actually bent by gravity. And we know that, in fact, that it is. During an eclipse, we can see that stars are not at the position they're supposed to be. And this occurs because light that's traveling from a star is bent as it passes the sun and hits Earth, and therefore it appears to be originating from another spot. If we look at it, we'll see that the star's position has been displaced. What's on the other side of a black hole? Well, nobody really knows, but a lot of people think something is there, and they call it wormholes, and perhaps they are gateways to other universes. There are some